Hello everyone. Today I am going to present my seminar on design evaluation techniques in software engineering. Software systems are becoming one more complex day by day. So before we start coding, it's very important to ensure that our design is correct, efficient and scalable. In this presentation, I will explain different techniques used to evaluate software design and why they are important. Software design is basically a blueprint of how the system will be built. It includes architecture, components, data flow, and interfaces. However, even a well planned design can have flaws. If these flaws are not identified early, they can lead to serious problems later, such as system failure or high maintenance costs. Design evaluation is the process of checking whether the design meets requirements and quality standards before implementation begins. Objectives of design evaluations are the main goals of design evaluations means that are to improve the overall quality of the software system, to identify design errors at an early stage, to reduce development and maintenance costs, to ensure the system is flexible and easy to modify. Early detection of issues is always cheaper and easier than fixing them after development. Key design quality attributes are when evaluating design, we focus on certain quality attributes that are maintainability, scalability, reliability, and efficiency. Maintainability means how easily the system can be modified or updated. Scalability, whether the system can handle increased users or data. Reliability means the ability of the system to perform consistently without failures. The efficiency means that how well the system uses resources like memory and the CPU. A good design should balance all these attributes. Let us check the overview of design evaluation techniques. There are multiple techniques used to evaluate software design. Some are informal, like reviews and discussions, while others are formal, like inspections and metric analysis. Each technique has its own advantages and is used depending on project size, complexity, and team experience. Combining two or more techniques provides the best coverage. No single method catches every design issues. Here you can see design reviews walk throughout inspections, prototyping, metrics base. And in the next slide we will discuss about this. First of all, design review. Design review is one of the simplest techniques. In this process, team members examine the design documents and provide feedback. It is usually informal and does not follow strict rules. The main advantage is that it is quick and helps in early detection of obvious errors. However, it may miss deeper issues because it is less structured. And on to moving to next walkthroughs. In a walkthrough, the designer presents its design step by step to other team members. Participants ask questions, give suggestions, and discuss possible improvements. This method improves team understanding and communication. It is especially useful for training new team members. Next is inspections. Inspections are more formal and structured compared to reviews and walkthroughs. They involve defined roles such as moderator or the reviewers. Moderator means leads the process or the creator of the design. Reviewers means examine the design. Examine the design and the process follows strict steps and checklists, making it very effective in detecting defects. However, it requires more time and effort. And moving on to prototyping. Prototyping involves creating a working model of the system before final development. It helps in understanding requirements better and validating design decisions. There are two types of prototyping: low fidelity prototypes and high fidelity prototype. Low means simple sketches or moderate, and high fidelity means interactive and closer to the final system. This technique is very useful when requirements are unclear. Next is metrics based evaluation and automated tools. This technique uses measurable values to evaluate design quality. Some important metrics include coupling, cohesion, complexity. Coupling means degree of dependency between modules. Lower is better. Cohesion means how closely related elements within a module are higher is better. Complexity means how difficult the design is to understand. Coupling, lower is better. In cohesion, higher is better. These metrics provide objective data to support design decisions. And next is the automated tools. Today, many automated tools are available in evaluate software design. These tools perform static analysis, detect design issues, and generate reports. Examples include tools that analyze code structure, dependencies, and complexity. They help save time, reduce manual effort, and improve accuracy. Some automated static analysis tools are SonarQube, Checkstyle or PMD, NDepend or JDepend. SonarQube detects code smells, security vulnerability, and technical depth. Checkstyle enforces coding standards and flag design antipatterns automatically. NDepend or JDepend visualize dependency graphs and measure coupling or cohesion metrics. Here we can compare the techniques. Choose the right technique based on the project phase, theme, size, and available resources. There are different techniques such as each evaluation technique has its strengths and weaknesses. Reviews, quick and simple but less detailed. Walkthroughs, interactive and informative. Inspections, highly effective but time consuming. Prototyping, useful for validation but may require extra effort. Metrics, objective but requires proper interpretation. So usually a combination of techniques is used. Can I say a real world example? Here you can see that. Let's consider an e-commerce system. During design evaluation, the team identified that the system could not handle a large number of users simultaneously. By redesigning the architecture early, they improved scalability and avoided system crashes during peak sales. This shows how design evaluation prevents major issues. Challenges in design evaluations are some common challenges we can see there: limited time and tight deadlines, lack of experienced reviewers, poor communication within the team, resistance to criticism or feedback. These challenges can reduce the effectiveness of evaluation. We can practice many best practices to improve design evaluation. We can start evaluation early in the design phase. Use simple techniques together. Encourage open communication and feedback. Use checklists and guidelines. Continuously improve based on past experiences. And we can conclude by saying that design evaluation is a very important step in software engineering. It helps in improving quality, reducing risk, and ensuring successful project delivery. By using the right techniques, we can build reliable and efficient software systems. After all, a good design builds software, but a well evaluated design builds successful software. Thank you.